So, hello everyone. I welcome you all to this sixth lecture of Python programming full course for beginners. If this is your first time watching this course, I welcome you. This course is designed for absolute beginners. We are learning Python from scratch without assuming that we have any prior programming knowledge before. So, if you are completely new to coding, you are in the right place. Before we move forward into today's topic, let's spend some time revising everything we have learned so far. So, revision is one of the most important parts of programming because programming is not about just remembering or memorizing the syntax, it's about understanding the concepts and practically implementing them or practicing them repeatedly. Um, in today's introduction, we will quickly revisit all the topics we have covered from lecture 1 up to the point where we have learned about numeric literals. If you have watched the previous lecture, this will strengthen your already available understanding. And if you have forgotten something, don't worry, we will refresh it together. So, without wasting any more time, let's begin. So, let's start from very beginning. The first question we answered was, what exactly is Python? Which was Python is a high-level interpreted general-purpose programming language created by Sir Guido van Rossum, and it was first released in year 1991. Now these words may sound complicated, but let's understand them. High level means Python is easy for humans to read and write. We don't have to worry about machine level languages and or the machine level instruction or binary code. And interpreted means Python execute our code line by line rather than converting the entire program into a machine code beforehand. The general purpose means isn't limited to one field. That is, we can build websites, we can build desktop applications, we can create automation tools, games, we can create artificial systems, AI systems also, then data analysis you can do with help of this. You can do cybersecurity, you can create use cybersecurity tools. Then it is being used in IoT applications, you can build cloud softwares and many more things. So this versatility of the is one of the biggest reason Python is loved by beginners as well as professionals. Next, we discussed why Python is so popular. As we already know that Python has a very clean and readable syntax compared to many programming languages. Python requires few line of code. It has an enormous collection of libraries. Its community is one of the largest in the world. And whenever you get stuck, chances are someone has already faced the same problem and shared the solution online. So Python is also platform independent. This means the same Python program can run on Windows, Linux, and Mac OS with very little or literally no modification. Later on, after understanding Python, we moved on to installing process. That's how you can set up the environment. We downloaded Python from the official website. During installation, we learned one very important option, which was add Python to path. But like many beginners, accidentally skip the checkbox and later wonder why Python command doesn't work in the command prompt of PowerShell. So adding Python to path allows Windows to recognize Python from any location. It's a tiny checkbox, but an extremely important one. Then once Python was installed, you can verify the installation. We open the command prompt and type Python dash dash version. This commands tell us which version of Python is installed. We also checked PIP, which is Python's package manager. Whenever we need external libraries, PIP help us install them easily. We will be learning few libraries in the end of this course so that you can be a bit more proficient in Python and have some experience over few available libraries which are famous. Then we learned about IDLE. IDLE is a Python's integrated development and learning environment. Think of it as a beginner-friendly editor provided by Python itself. It allows us to write, run, save, and edit Python program without installing anything. Although professional developers often use editors like VS Code, PyCharm, Anaconda ideally is perfect while learning the basics, but you would require an code editor whenever you are growing. So after doing all this, we learned that Python has two working modes. The very first interactive mode and the other one is script mode. Interactive mode, as we know, is useful when we want to quickly test few lines of code. We type a statement, we press enter, we see the result immediately. It's great for experimentation and however, interactive mode isn't suitable for writing big programs or large programs. For that, we use scripting mode. In script mode, we write our code inside a file, we save it, we run it, we edit it later as per our requirements. We can share it with others. The extension is .py. Professional programming is almost done in scripting mode. Then we wrote our first Python program, uh, the famous Hello World. Although it looks very simple, it represents the beginning of our every programmer's journey. The print function displays output on the screen. Everything that appears inside print gets shown to the user. After that, we explored the print function itself. Function in much we did greater details. We explored. We learned that print can display strings, numbers, expressions, mathematical expressions, then multiple values it can show. It can display variables, even the result of calculations we did. We also experimented with different parameters like set and end to to customize the output. And these may look small features today, but later they become very useful while formatting data. Then we discussed Python character set. Every programming language needs a set of valid characters from which programs are written. Like Python mainly uses uppercase letters, lowercase letters, digits, special symbols, then white space characters, and without these characters, writing code wouldn't be possible, of course. Next, we came to the identifiers. An identifier is simply the name we give to different program elements. Um, an identifier is simply the name we use it for variables, functions, class names, object names, module names. So everything needs an identifier. Imagine reading a program where every variable is named x1, x2, x3, temp1, temp2. It becomes confusing. So, meaningful names make programming much easier, as I told you in the very last lecture. But identifiers follow certain rules. They can contain letters, digits, underscore. They cannot begin with a digit. They cannot contain spaces. They cannot contain special symbols like at the rate, hash, ampersand, then and these are generally not allowed inside identifiers. So Python is also case sensitive. This means that every same looking variable or identifier may look common to you, but they can be three different identifiers. We can make three pairs using age itself. I'll, so these three variables, all three are age, but these three, just because Python is case sensitive, are three different identities or entities, we can say. Moving forward, this we studied in the very last lecture only, but before that, we also studied that keywords. Keywords are reserved words that already have predefined meanings inside Python. For example, we can use if, else, for, while, and other 35 keywords, which is available in the version I'm using right now. Depending on the version, keywords can change number of keywords. There are 35 of keywords. If you want to see it, you can do import keyword and then you need to print keyword.tw list. Since these words already have belong to the language and or I can say it belongs to the Python, we cannot use them as a variable. That's a strict rule. If you try to write if is equals to 20, Python immediately produce an error because if is reserved. The error will be an syntax error. You can see it on the screen also. If I try to run this, if is equals to 20, and I try to run this, you will see a syntax error. But as we know that Python is case sensitive, if I make this capital, then it will be as good as perfect. Moving forward, we covered conditional keywords. We basically categorized, we went through all the categories of keyword: conditional keywords, looping keywords, logical keywords, exception handling keywords, and function keywords, class keywords, then Boolean keywords, and many others. So basically, grouping keywords into categories make them much easier to remember. Instead of memorizing 35 words individually, we understand their purpose. We should know that what is the purpose of that keyword. Then we move towards literal. We started with literal. We covered numeric literals. Many beginners confuse variables and literals. Let's understand the difference here. A literal is nothing but simply a fixed value that is written directly inside the source code. Whenever we write 10 or we write 20 or we write a pi value which is 3.14, it can be true, it can be hello within quotes. These are literally literals. They already represents actual values. So literals are different from variables because variables store values, but the value which is being stored is a literal. So literals are the actual values. For better visualization, I'll we can take example like this, that this is an identifier and the value, and this is a literal. In the very first lecture, I told you that we can't that a Python program cannot start with a white space. So here you can see, if I add a white space, it will throw an error. So here we go. This is an identifier because it identifies something, it refers to something, and this is the actual value where which it is referring to. So this is a variable, also known as identifier, and this is a value, a fixed value, which is literal. Moving forward to the next concept. So as you can see, operators, but before that we still need to cover these collection literals, Boolean literals, then string literal, and numeric literal we did covered in the previous lecture. So let's start with string literal today. So as you can see on the slide, string literal represent text and are created by enclosing characters within quotes. Python supports several ways to define string depending on the use case. So here you can see we have 4 types of string literals. One is single quoted strings, another is double quoted strings, third is triple quoted string, and the fourth is raw string. Now I'll show you all these strings so that you can get a better understanding over this. If I show you the VS Code screen, I hope it's visible. Yes, it is. So now we have string. So you can make something, typecast something into string using this function, which is str with parenthesis. Any value you do, it will become a string. If you print it, you print type of it, you will see the output. You can see the class it belongs to is string. But if we change it, let me comment it out and type it again. Just 12 if I do, and then I run it. You can see the class has changed. It has become an integer type. We have to see four types of literals. One is a single quoted, and double quoted string, triple quoted string, and the raw string. Now, how we distinguish them? This is single quoted string, any value which is written inside these single quotes are single quote string. There's literally zero difference in this string and this string. They are both same. To see it with your eyes, I'll take one variable str1, then another str2. Now here you can see there's literally zero error. So let me close this thing and close this also. Now here you can see we have two strings. Now I'll print a third string where I have to use triple quotes. So any value which is written inside these triple single quotes, then we have, let me select it so that I can copy paste string 4, this thing. Now here you can see any value which is written inside these triple single quotes. So these are three things which I am currently referring to. They might look different, but they actually are not. They all are same. Now if I print the type of all these, so all of them will refer to same data type. But for now, let's see it. We got four strings, so I have printed it 4 times, pasted it 4 times. Now, if I run it, for that, let me open the terminal. Now, here you can see. So if I run it, here you can see all four things are belonging to the same class, which is string. So there is literally zero difference. All these are same. They don't behave differently. Now, where comes the actual difference? Do you see these triple quotes? That is this one. So the main difference is it is multi-line string. You can write it is a multi-line string. You can type it, use it as much time as you want. But the actual difference is, let's say, to make you visualize it much better, I'll create a string str1. I'll make a triple string. So this is first line, then this is second line, likewise third line. If I try to print this, what will be the output? Will it be a string within a single line or a string with three different lines? Let's run this. Here you can see the output is coming in three different lines as we wrote. So what do we understand from this? We understand that a triple line code behave uh, creates a string as it is, and it is multi-line. Now, if I do for a single line string, single quote string, what will happen? Here you can see it will throw a syntax error if I try to run it. Syntax error, unterminated string literally, because we haven't terminated it yet. But don't worry, if you want to type something in multiple lines, in this you can still do it. You just need to do this. You need to add a slash so that Python knows that okay, so there is a multiple line string. There's string which is going in multiple lines, but the difference here is it won't be treated as a multi-line string. It will be treated as a singular line string. Every enter won't be considered as a new line, but it will be considered as this null character only. So that's one behavior which you should know for the strings. If you for the single strings, if you want to type it in multiple lines, you need to use this backslash or this slash so that you can use it. And whenever you want to write a multi-line message, you can use triple quotation strings. And whenever in Python, we have this concept of comments. So comments are those lines of code which is not meant to be evaluated by the program. So this is a comment. This hash, which you are seeing, is a comment, a message for the peer developers or for the person whoever is going through the code to make his her life simpler, easy to understand the code, so that they spend a bit less time to debug something whenever they are working over a piece of code. So comments make developers' life a bit easier. One way is you use hash, but same thing. Now you can't use this backslash concept here or the slash concept here. You can't use it. It's a it's a comment. So another way to type a comment, multi-line comment, is you just use this triple line quotes. Multi-line comments we can say. So this will be considered as a multi-line comment because these lines won't get evaluated. And if I try to run this, let me clear this. And if I run this, you can see there's literally no output, no error, nothing. Because these are just comments. And if I remove this and if I run this, see, it's literally the same. So what will happen if I do this? You can see if I run this, empty line has come here because the print statement. We can move forward to the raw string, which I already told you, but we will learn few new things. So let's create an identifier, raw string. In the previous lectures, I have told you about formatted string that we use this, and these are the placeholders. So right now it is showing an error. That is expected expression. It is expecting an expression here. Let's give few expressions here. Now, if I want to print this, what will happen? What should come on my screen? As I told you, as it is a formatted string, that means these parentheses, not parentheses, but the curly braces, these are acting as a placeholder. These will get evaluated and will be shown as the calculated unit. So 1 plus 2 will give me 3. Then a white space character will come here. Then what will happen? 2 plus 3 will get evaluated. So the expected output, which I assume should come, is nothing but this thing. If I write a string like this, and if I do this, an equivalent of this should come. Let's try to run this. So if I run this, Okay, I haven't printed the raw string, my bad. So let's print it real quick. And now hear it and run it. So here you can see it is showing me 3 and 5. That's exactly what we predicted. If you want to see the output of this, let's run this also. Here you can see the same exact output which we guessed. But what should we do if we want to print this thing? That is what will I do if I want to print this exactly? So will it work? Yes, it should work. It will print it as it is these values. But what will happen if you want to write an address? I'll show you something that can you see this? This address from C drive users, my name, then app data, local program, Python, Python 313, Python 3.exe, then D drive, Python tutorial, demo.py. What is this? This is an address which needs to be read. Now, what will happen if I want to write this address? Here you see, we're using these backslash. Now, if I do this in a single string and I write something, write name and x, let's say, and if I print the x, what will happen? Will it give write this name or will it give wait? So let's just don't do this. So if I run this, there you see write backslash name. If I do this, there you see this has become separate. This is the behavior coming due to the but if I do this, you see the issue here, the backslash n, it is acting as a new line character. But I want to do this. How will I print this thing? This is the issue which we will face someday. Now to deal with this, we have the concept of raw string. How to make a raw string? We just write a character R in front of the string, and if I print this, there was literally zero need to do this. I'll just rename it, and if I run this again, you see the right name has come as it is without a new line character. So this is the behavior which we expect from the raw string. And the earlier behavior I showed you with the formatted string, we use placeholders to evaluate whatever values we are dealing with. So I'll just paste, copy it. And here we have this and we have this. So this is the actual raw string. This is a normal string. Normal string. If we add a f in front of it, it will become a formatted string. We have multiple ways to deal with the strings. I will demonstrate those also to you. Just give me a second. So let's see those things also. So here you can see the theory portion. We already know how we can do string concatenation. We can use the addition operator, which is a mathematical operator because it is overloaded. It can perform and it can behave in multiple ways. I'll also teach you how to overload or how to overload an operator. So don't worry about it. You will learn this in object-oriented programming. So let's focus on this. Here you can see to join strings, we use string concatenation, which is name. Here you can see name is equal to Rishabh is given, age is equal to 20 is given. If you try to print it, print name. So this name is a different string, and here the identifier which we are dealing with is referring to reshift. So it is equivalent of nothing but it is equivalent to this. Okay, it is equivalent of this name, then plus, then reshift. This is equivalent of this. So whenever you'll run this, equivalent string will be this, and this will be printed. So if you print this will be our expected output with a new line. Another thing will come. So as they have typecasted the age, because to add it or to concatenate it, they need to typecast it. If you do this, let's say we create a variable age is equals to 20. Okay, it's thrown an error because my numlock wasn't working. Now, if I try to print age plus age, what will happen? Can you expect? It will throw an error, which is a type error because it cannot concatenate. Now it is asking you to import platform to deal with this. But to fix this issue, we can just typecast it here. If I run this, it will give us the desired output, which was so for string, you can understand the addition symbol as a glue that it joins two different strings. It can join multiple strings. So moving forward, so the pros and cons you can see, it is simple for small strings. Cons cannot directly concatenate non-string type as we see the error here, and hard to read for long strings. Yes, that can be an issue while dealing with long strings. So let me zoom it out. Using commas in print, we know that it generates a white space in between. We can change using these sep and end. Now, yes, I was talking about the percent formatting. It is an old style to format. So, as I told you that we use placeholders. Instead of this, we use specifiers. So this is a string specifier, which is percentage %s. For integers, percentage %d would be used. For floats, percentage %f and hexadecimal percentage %x. For octal, it's percentage %o and percentage %c for the character. Now, here's an example. Let's use this itself. Now, if I run this, we need to exit the okay, let's run this. Here you can see 3.14, the same output as we expect from a formatted string, which is this. If I run this, same result. Now, what will happen if I use, let's for a common understanding, those who don't know typecasting, like what zero, let's create a table here. So let's have a look here. In binary, we have 0, 1. So to convert anything into binary, you need to just divide that number. Let's say if I want to convert 10 into binary, I'll divide 10 by 2. But I'll get 5. Remainder is 0. Now I'll divide 5 with 2. If I try to get the results, I'll get 2 and 1 as remainder. Now I divide 2 with 2. I'll get 1 and 0 remainder. Oh, that's it. Now our number is 1010. from here. This 1 is this, and this 0 is this one. So the values goes like 2 to the power 0, 1, 2, 3, 2 to the power 3. So this is 8, 8 plus 0 plus 2 to the power 1, which is 2 plus 0. So we get 8 plus 0 plus 2 is equals to 10. You can watch any tutorial videos for type conversion between binary, octal, hexadecimal. So likewise, you can divide with 8 with 16, and these are the relative characters. For 0, it will be 0. For 1, it will be 1. For 2, 2, 3, 3, and so on till 9. For 10, it will be A. For 12, D, 13, C, 14, D, 15, E, 16, F. Not 15, F. So it has total 16 characters from 0 to F. Now, let's have a look on our. So here you can see the output is A. So what does it mean? It means that hexadecimal character which we are trying to print is 10. So it is A. Likewise, if I make it 15, and I run this, it is F. If I make it 16, now logically 15 plus 1, that is F1 should come. Now if we run this, it is showing 10. Now let's try to understand why it happened like this. So because at the 16 16 to the power 1, then 16 to the power 0. So at 16 to the power 1, 16 raised to the power 1 plus 16 raised to the power 0 is equals to 16. So it is true. So hence that's the output. Now what I did wasn't actual correct way or method to evaluate that statement. So that's why we saw something unexpected. Now if I make it 20154 and now I run it, you see 4 EVA. What is this? If you do 16 to the power 0, 1, 2, 3 into 4 plus 16 to the power 3 into E, which is this 14 plus B, which is 11 into 16 to the power 6, just 16 plus A, which is our 10. So it will be equal to 20154. And now if you see other specifiers, so we have integer, we have floating points, the hexadecimal, octal, and percentage C character. So if you do percentage C of characters, and let's say for now I make it 65, and I'm run this, you will get A. If I make it 97, we should get small a. So this is the ASCII character code which is getting converted. You can uh, print whatever data type you want to get in front of you. If you want binary, you can use just percentage %B. Let's try to use it because even I forgot how to get binary. If I do percentage %B and I write 8, what should we get? We see an error. So let me, it is showing that, okay, I think we should use like format function, then we can get this. So we use format when I write this hours. So Then I do this. This should give me binary. Okay, yes, now it is working. If I do it, so this is the way. And there is also a function in Python. So if you do this bin 2, then you will see the binary equivalent, and the zero base telling you that it's a binary type. If you will do opt2, you will see 0 and 2 here. Likewise, if you do hex and you do 4x4, so these are four functions. These are three functions you should know, and this format function. And instead of using format, you can just use this only. This format is a good function. It allows us to format the string in different ways, but for now it is not necessary. We can move forward to our query part again. So this is percent formatting. We write string with percentage, and we use these specifiers: percentage s for string, percentage d for integer, percentage f for float, percentage x for hexadecimal, percentage o for octal, and percentage c for character. Then the format method, string dot format, then whatever name you want. So we write the string in front, we create placeholders, and then we use dot format function and pass all the values which need to be replaced. So here you can see this is 1, this is 0. So if I'll print this, there's no to change. We are. If I paste it and I enter it, you can see that Rishabh is 20-year-old is coming. But what will happen if I remove this? If I remove this 1 and 0, if I do this and if I run it now, 20 is Rishabh years old. Why it is happening? It is happening because this is at 0th position, this is at first, this is at 0th index, this is at first index. So we here explicitly, forcefully told the print function that that format function that the first placeholder will the 0th placeholder should contain the value which is at first index, and at the first another next placeholder it should store the value at 0th index, and by default it is 0 1 like this. So then we can use name arguments also. So this is the named argument method. Here we create identifiers, and in dot format we just forcefully write it. There is no need to then add the index. This is width and alignment. We use this to uh, for bill formatting basically. So if you will print this, this will be the output Python. As you can see, what it is trying to do, it is trying to tell that there should be only 10 characters from the left, and it is telling that there should be only 10 characters from the right. So if you will count it, 1 from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is used to align it in the center. So these are number formatting. So this is the number. If you will print the number as it is, it will get printed directly 1, 2, 3, 4, 5, 6, 7 without anything. But if you will do this, commas will come. Then for decimal places at certain precision you want, you can use this. colon dot then nf, where n represents the number of precision points you want. It cannot be negative. Uh, it should always be positive, that is 0 to, and it can be 0 also. Then this is the recommended one, the formatted string which I taught you. Let's move forward. We have covered enough in strings. So here's few examples, and I told you why we use raw string. Now for Boolean literals, there isn't much. There are only two values, true, false, and we also have none. So true, we have false, we have none. As we are done with keywords, so we also know that there are some logical keywords which are there. So these are those. We also we can use true and false. If I do, I'll get false, because and function, whenever we use and operator's truth table is both the values should be true, then only it will return true, else it will always return false. So if I do true and true, I'll get true at that time only. If any of these is false, if I do true and 0, I'll get 0. If I do 1 and 0, if I do 2 and 1, I'll get 1. So I'll tell you what is happening here in the lecture of operators, when you will understand how operators operate over these, because there's a concept that still needs to be covered. So we have gone through literals, Boolean literals we have covered. So this is one example. So here you can see that, okay, is A is equals to true, B is equals to false. So the output we are getting when we print A comma B, so as expected, true first, then a white space because of the comma, and no change in the sep parameter argument. So true and false. If then they printed, then they checked whether one is equals to true. It gave true. It evaluates to true. That's why it gave us true. Then we did true print 0 is equals to false. That's also true. That's why it gave us. That's why it gave us true. Now we have done these three statements. If we move to the fourth one, now it is showing true plus 5. As we see here, that true is equivalent of 1. So if you do 1 plus 5, you will get 6. So in the output screen, you get 6. If you do print 0 plus 7, you will get 7. That's it. As simple as that. We will explore it in much more depth when we will be covering operators. So we will cover operators in the next lecture. For now, we will focus on literals, because in the last lecture we were unable to cover it all. Now we have collection literals. So in collection literals are used to create multiple values in a single object. That is, you can refer to multiple objects using one single reference. So here I can refer to first, second, and third using just ranks. The data type which you are seeing right now on the screen, which I'm trying to highlight here, is a list. So this is a list, the one which I have highlighted in yellow, and let's erase it. And the one I'm coloring in red is a tuple, and this one is a dictionary. We will learn all the methods which are available over these data types. Don't worry about it. It's just a matter of time. We will be on those topics real quick because our fundamentals are becoming stronger day by day. So it won't take much time in the upcoming lectures. Now we will focus on these one. That is list literal, tuple literals, dictionary literals, and set literals. So these are four data types for now, which we will be learning in the remaining lecture for now. So we won't go in the depth of these for today because they have multiple methods which you can use over them. So we will just have an overview look which will make which will give us a little hint at how these are and how you can use them. So let me open my screen for you. Now it is visible to you all. So the first literal type collection literal is list. So what is list? List is a data type which can contain multiple values in an order. So it is ordered, it is mutable collection, and now these term ordered, that means it has a specific order of its element. And by mutable, it means you can change it, you can do changes within it in place. That you can add an element, you can delete an element after the creation of that list of that data type. So list is mutable, it is ordered. How you can create list? You can create list using the function list, and if you print it, an empty list will come. And if you another way is you can just do this. This will also make a list. Now if I run this, okay, let me consider this. So here you can see the first list, it is printing the list with which has been created with the list function, and this one which is being created with the square brackets. Now, as I told you that it is an ordered data type. What does it mean? It means that it has a certain index order. So for now, I'll use this. Let me run it. Now, if we can access these elements with the help of their index. So for that, I'll use the for loop, which we learned in the previous lecture. So you can create, you can add elements, you can create a list with elements like this, square brackets, then every element separated by a comma. There's no such hard fast rule that you need you need to have only this thing, that only same data type. You can have multiple data types. You can have a list within list, a nested list, a tuple, a dictionary in it. You can do as you can make it the way you want. You can't have a tuple like this. For a tuple, you need to do this because else it will be a simple integer. So for that, don't worry about it. I'll tell you. For now, let's focus on list. So if I run up, try to print list one, now you will see that these are the data types. Key value pair, they have one value one, let's say for now. Two value. If I run this, here you can see this is a dictionary, the one with curly braces. It contains key value pairs. The one with parenthesis is a tuple. It is also an ordered pair, but the thing is, it is not a mutable data type. You can not do in-place changes. Now, what makes us come to the confusion that it is an mutable data type, list is a mutable data type, and tuple is not. So for that, let's have a look for list now. So I'll create a list with name LST. I'll create it. Now, if I call list, an empty list has been generated. Now I can add elements to it using dot append method. If I do this again, and now I call it, you can see 1 comma 2, it works. So this is one way which confirms that it is mutable. Now let's do one thing. Let's help list if you do. Here you can see that okay, class list on in module built-ins class list object it do what? Okay, so I had to do this because it is too much text to go through. So here you can see all the methods which are there. You can use add, that is our plus symbol. This is the name for the method or the operator. So if you want to overload it for class, you can use this thing. We have contains the delete items. So you can use pop also. So for that, okay, we have list. So you can use list.pop to remove elements from it. It will show that okay, I removed two. If I call list, only one is remaining. This confirms that okay, it is mutable. For now to confirm that it is an ordered pair, how will you confirm? I'll create a list using okay, my name is Rishabh. There's a function called split. You can use it. It will just split the a string into a list using the whatever argument you have given to it. If I'll print list now and I run this, I will see my batch. Clear it and let's do m.py. So here you can see it is printing my name as Rishabh. There are 4 elements in here. Now there's a function called len, which gives the length of the list. So if I use this and I do for I in range, now I pass this. As we know, it will run from 0 till a value less than n. So here the n is length. Now the length is 0, 1, 2, 3. Not 0, 1, 2, 3, 1, 2, 3, 4. So it will run from 0, 1, 2, 3. So if I print index I is our list, if I run this, we'll see something beautiful. That at 0th index, my is there, at first index, name is there, at second index, is there, and at fourth index, at the third index, Rishabh is there. What will happen if I make it more than that? You will see an error there, index error. It will work till there, but it will throw an error when the for loop will reach that okay, I'm seeing an error here. As I told you, we also have try and accept blocks. So if I do try here, if I do accept here, so I think we need to indent it. We indented it. Try accept the print exception. If I run this, you can see till here it is working, and as we receive our error, it is printing exception. There's also a finally keyword which you can use. End of program. Now this is list. This was list. Now let's move to the second literal, which is tuple. So tuple is also an ordered list, an ordered literal, but it is not mutable. It you cannot do in place changes. It is fixed. So whatever tuple you have created, you can create a tuple using the tuple function also. So let's create a tuple and let's try to print it. So here it is. Here you can see, and to confirm the type, uh, here you will see class TPL tuple. So so the class is tuple. Now if I try to add element to it, it's tuple one. For example, I'll for better understanding. Let's say I create this 1, 2, 3, and I print it. Okay, and now I make list of 0, 1, 2. That is the last element to be 7, and now I print it. You will see that you will see that the the value which was at the second index is now changed. It has become 7. So this makes that its list is mutable. Now, as I claim that tuple is immutable, so what will happen if I make it a tuple? So here you can see if I try to print it and I try to run it. Here you can see that list 2 tuple type error. Tuple object does not support item assignment because it is immutable. You cannot do in place changes. You can only do it when it was created. You can have an element here and you can like add an element to it like list of 0, 1, 2, 3. It is dot append 5. I do. So I have printed list. Now if I do this, we can change the elements which are mutable within it, but we cannot change a tuple. So I hope you get it. What are lists? What are tuples? Now we have dictionary. It's a key value pair, literal, where we stores value in it. Uh, Using you can create a using dict function you can create a dictionary. If I try to print type of it, you will see that class is dict. Okay, so it stores values in key value pairs. So here this one will be a key, and whatever I'll store you after this column, whatever value I'll be placing. So this is value 1. You can have anything. You can have a set, you can have a dictionary itself, you can do whatever. So this data type is a dictionary key value pair literal, which is dictionary literal. So there are multiple operations here, which we will be learning in the upcoming lectures for these specifically. So don't worry about it. We still got ample of time to learn. We need to know everything so that we get better every day. We won't bombard everything a single day. We will move with the lecture slowly and slowly so that it won't become tough for you to remember everything in a single day. So here you can see that okay, this dictionary got printed and the data type is being in this order. So if I do x dot keys, you can see that all the keys will get printed. If I do x dot values, all the values will printed, and if I do, so that's it. There are multiple methods. So these are object which need to be typecasted to be seen. So let's convert it into a list so that these objects, and these are iterable objects. So you can iterate over them. That's why we can typecast it into list. Okay. So It is saying that list x dot keys is not working because so uh okay, yes. So we are not calling the method, we are just referring to it. That's why we saw this error. Now we can see. Now the error has been resolved. Now if I remove this and now I run this, then you can see this object. This was happening due to the object. Now we will typecast it, simple as that. So these are the methods which we can use for dictionary. It's not ordered. It is being stored in key value pairs. Now we have sets. So sets are there. You can create a set using the set function. Now if I print type of it, here you can see, let me clear it. Now class is set. We can create set using curly braces directly and elements like this. The property of set is it is unordered and it is all unique. It can only store unique characters. So I'm printing the type, sorry. So if I print this, you can see it is 1, 2, 3, 4, 5. It is unordered. We will see it in the upcoming lectures when we will be performing operations over it. So let's say there's an set 1. I'll just make it S1 and S2 so that becomes much more easier. S1, S2. I make 5. We got what? 6, 7, 8, 9. S1 dot union. If I do it with S2, now if I run this, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I try to get an index of it, that is for I in S1, print I. If I try to do this, I'll get the elements. But if I try to do print S1 0, what will happen? Will it give us the desired output? No, it will throw an error, which is a type error. That set object is not subscriptable, so it is not indexed. Its value can get shuffled. You have to use sort whenever you want a desired output. So there are multiple methods we will be learning in the upcoming lectures. So these were the literals, the collection literals which we studied in the today's lecture. In the upcoming lecture, we will cover what are operators, different types of operators, and after that, our real journey of programming will start. We will start practicing different programming questions, which will help you grow different methods how you can solve question efficiently and in multiple ways. So for today's lecture, that's it from my side. Keep learning, keep growing, and keep practicing.